What do they want from you? It says that an astronaut on the moon drops a feather from rest. Guys, I want to highlight this question here. This statement is always ignored by the students. Whenever you see the word "is from rest," this means to say the initial velocity is 0 already. A lot of students, they're always very sensitive to these numbers here, and they don't see the word rest. And acceleration due to the moon's gravity is blah, 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 which is this, either gravity or acceleration. All right, there is no air in the moon. The feather falls for 4.5 seconds before it hits the ground. State on figure 1.1, draw the speed time graph of the falling feather. Guys, if they say that the speed is the acceleration is 1.6 meters per second square, it means to say for every second that goes by, the speed increases by 1.6 meters per second. Right. So what you're supposed to do is you're supposed to identify that here is 1, and somewhere along here is going to be 1.6. I don't know where it is, right? Then with this line here, you're going to draw one line that starts from here all the way until it goes until it's 4.5, which is somewhere around here. I mean, you can use a ruler, right? I don't have a ruler, but this will be the best thing I can do, right? Until it's 4.5, then this is your line already. Okay, you have to identify this information. It says 1.6 meters per second, means to say each second that goes by is going to be 1.6 meters per second increase. Right. Alternatively, if you don't want to do this, you can also do the calculation. A equals to B minus U over T, right? Which is going to be 1.6 equals to final minus 0 over 4.5. With this method, you should get the exact same answer for your B, but then you'll find a point here instead, which will be some number, I don't know whatever number it is. You can press in your calculator. Okay, either method is fine, but you have to draw it. Then after that, they ask you to find the distance fallen by the feather. How do I find the distance in a speed time graph again? Area under the graph. Do not straight away do whatever number here multiply by 4.5. You will have found the area of this rectangle instead. Instead, what you're supposed to do is whatever number that you found here just now, right? And this is your 4.5, right? That number multiplied by a 4.5 multiplied by half because it's a triangle. And you should get how much? 16.2 meters. You all get 16.2 meters? Yeah. So this is your distance traveled. Then after that, they say sketch the shape of a speed time graph for the same feather falling on Earth. Right now, what's the difference between the moon and the Earth? That's wrong. That's correct. Yeah, Earth, there's air. It means to say there is air resistance going on, right? And whenever there is air resistance going on, it will eventually reach very good terminal velocity. Means to say you're supposed to draw a decreasing gradient graph, and ultimately you'll have a flat line here. Make sure that this is a flat line written by a ruler, guys. I mean, drawn by a ruler. Right. Welcome back, boys. You're late. Hurry up, sit down. Okay, then after that, the last question here, they say explain the difference between the speed and velocity. Include words vector and scalars in your answer. Guys, vectors are things with what and what? Magnitude and direction. And scalars are things with only magnitude. So this is how you're going to answer it. You're going to say something like speed is a scalar quantity. It only has magnitude. Velocity is a vector quantity. It has magnitude and direction. Okay. Okay, guys, any questions for this one here? Okay, if you have no questions, just proceed with the next one. You have 5 minutes, guys. Like I said, you don't have time. Just start doing your questions. Every 5 minutes, either you know or you don't know, only then we're going to discuss the answers already. What do they want from you? It says that the boat in B is moving due west with a speed of 6.5 meters per second. West is in which direction? Left or right? It's the left, right? So this thing here is moving 6.5 already. Let's say a due south of another 3.5 here. In the space below, draw a scale diagram to determine the size and the direction of the resultant of these two velocities. State the scale you're supposed to use. Guys, first and foremost, you're supposed to draw a mini diagram, right? Like I told you 1,000 times. You have one speed that is acting 6.5 in here, right? And you have another speed that is acting 3.5 here. Which direction is your resultant velocity first? Is it in the 10 o'clock direction like this? Or is it in the 7 o'clock direction like this? It's definitely supposed to be the 7, guys. If you drew the 10 one, you are definitely wrong. So because you know that this is your resultant, right? Then what you should do is you should shift either one of the axis downwards like this, which will either give you a triangle like this, or you could shift this one to the other side, which will give you a triangle like this, right? And you'll notice that regardless of whichever way I shift it, the directions are all still the same, right? Then after that is for you to draw already, all right? The first thing you want to do is draw the scale, right? If I look at this information here, right, look at the box given here, I know for a fact that I'm supposed to use 1 cm to 1 meter per second. If let's say right, your initial assumption is wrong. If let's say your initial assumption is wrong, your diagram looks something like this, right? You're wrong. Even though you drew the correct diagram, you are wrong because you need to use at least 70% of the given space, right? But if you do this scale correctly, you have drew something like this. You will either drew something like 6.5 cm here, then 3.5 cm here. Then after that, you connect these 2 points, right? And you'll find the resultant velocity. How much is this? Anyone has the answer? How much is the resultant velocity? Should be somewhere around 7.4. Did anyone get 7.4 cm here? Yeah, if you round 2 centimeters, it's 7.4. If you got 7.4, you are on the right track. With this 7.4 cm, as you labeled here, you're going to state that the resultant velocity is 7.4 meters per second. Because they don't want the scale, they don't want the cm, they want the velocity. Right. And finally, you're asked to find the direction of the resultant, right? Which is going to be like, you measure this angle here, however much that angle is, right? Let's just, I don't know how much this angle is, let's just say this angle is 30 degrees, right? Then you see 30 degrees from the 6.5 meters per second. Or if you measure this angle here, let's say it was 60 degrees. Let's say 60 degrees from the 3.5, whichever one, it doesn't matter. Whichever one. Okay, guys. Anyone has any questions for this part here? Anyone uncertain what to do? For those who have no questions, you can proceed to the next one. You got both correct. Direction southwest. I think southwest is acceptable also. Yeah, usually the ones for the angle. But frankly speaking, this question is a bit vague. They did not specify correctly. Okay, guys, please proceed to the next question. Once again, you have 5 minutes. Guys, if you look at these kind of questions here, what phenomena is this again? This is diffraction. In diffraction, I've told you guys 1,000 times, right? It will either be a nice Wi-Fi shape or it will be a retarded Wi-Fi shape, right? That looks something like this here, right? In what scenario will it be the Wi-Fi shape and what scenario will be the retarded Wi-Fi? What's the condition again for a very nice diffraction to occur? Good. The scenario here is that the wavelength must be larger than the gap, right? Then you'll have a nice Wi-Fi shape. But if it's the opposite scenario, your gap is larger than your wavelength, then what's going to happen is you'll have a retarded Wi-Fi shape here. Yes, and in this scenario, which one is it going to be? The retarded one. And like I mentioned, guys, when you're drawing refraction, there's a few conditions. Number one is that it must start from the gap. I mean, you say if you drew the first one like this, you are already wrong already. Because it must start from the opening of the gap, right? And it will look something like this, right? You can draw it nicely with your pencil. Then the second condition is, how must the wavelength be? Will it change? The wavelength stays the same after diffraction, right? So meaning to say, however much this looks like to you, you're supposed to draw at least from the eye level equal distance, right? It doesn't have to be exact, but at the eye level, if you do something like this, straight away wrong. Because obviously from the eye level, these two are not the same wavelength already. The wavelength must be the same, and thus you're supposed to draw something like this. I mean, you can draw it nicer. Shit. And you need to draw at least 3. Okay, the equal wavelengths, at least 3 diffracted waves, and it must start from the gap here. These are your conditions, right? Okay, everyone? Yes. For those of you who erased the first one, especially those that are in my class, hope you guys remember this for the final time. Okay, then after that, blah, 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 this is exactly what we drew already. And this one here, obviously you can see that this time the wavelength is much larger than the gap, right? And obviously this time it will be the nice Wi-Fi shape, which is the same condition also. It must start from the gap, and then it must, from the eye level, look like they have the same wavelength. Shit. Yeah, something along this line. I mean, you can draw better with your pencil, right? But it must be the same wavelength before and after diffraction, because wavelength does not change after diffraction. Yes? Okay. Then after that, this one here. Guys, I think some of you guys did not hear me say this before because it was not included in my notes, guys. P waves are what waves again? We just went through this yesterday for those who were here. They are longitudinal waves, and S waves are transverse waves, right? They are transverse waves here. So they ask you to place one tick for each of the type of the wave to indicate whether they are longitudinal or transverse. Electromagnetic for sure. Transverse. This one longitudinal, this one transverse. Sound wave, longitudinal. Ultrasound. So these are your picks for question number 3. Okay, anyone has any question for question number 3 here? Good, excellent. Please proceed with question number 4. It says that a wave in the air is incident on a glass block. Figure 7.1 shows the wave fronts at the air glass boundary. This is the air, this is the glass boundary. The arrow shows the direction of the travel of the wavefront. This is your direction of the travel here, right? First and foremost, they said that the wave undergoes reflection and refraction, guys. Right? And they want you to draw the reflected waves first. Guys, if you're asked to draw the reflected waves, one very easy way to do this is to identify where the wave is heading towards. By right, if you think about it in terms of light waves, if this ray of light hits the air glass boundary, right, it's supposed to be reflected exactly the same angle, right, with reference to your normal. You say if let's say here was 70 degrees, here would have been 70 degrees also, right? Right. So with this direction of the wave, you can actually start to draw the wave fronts, right? Because I said that the wave fronts are always how many degrees to your direction of the wave? How many degrees should the wave front be with reference to the direction of the wave? Whoa. Wow, only one person know this. It's 90 degrees, bro. Everybody. Yeah, it's 90 degrees, right? Your wavefront, because with this, then you can draw. You could either draw either one of it. You could either draw your direction here, means to say you draw your wavefronts here. Once again, when you draw, make sure that your wavelength is the same, because once again, reflection, does not change the wavelength. Alternatively, if you don't want to draw this, I see some of you guys, you drew something like this, right? That is also correct, but you better make sure that the angle is correct. You better make sure the angle is correct, guys. Okay. And bam, you get your 3 damn marks for drawing this. All right. Then after that, they ask you draw the refracted waves. Refracted waves means to say that the light waves is actually going into the glass, right? So will it bend towards or away from the normal if it's going into the glass? Will the direction of the light wave bend towards or away from the normal as it travels from air into glass? It's going to go towards, because the speed of light is slower, guys. So you're supposed, if let's say this was the original pathway, you're going to draw one direction here. And with this direction here, you can start drawing your wavefronts already. You draw, make sure that 90 degrees, then you could either drawn something like this, indicating that it has slowed down, or even if you drew something like this, even if you drew something like this, it's correct. Just to make sure that they are all parallel, then you have gotten your answer already. Yes, everybody? Any questions from this part here? Then after that, they ask you the transverse wave is produced in a long horizontal rope. The rope is much longer than the wavelength of the wave. But the rope is all. In the space below, sketch a diagram to show the appearance of the rope as the wave passes. Label 2 important features of the wave. You draw a transverse wave law, right? And then what are the 2 important features are? It could be anything, guys. Starting off with the propagation.
Yes.
No, that's not a feature of the wave. Where's the crest? Where should the crest be?
Oh.
At the top of the wave, you either write as crest or peak, guys. It's either known as crest or peak, and this part here will be known as your throw or trow, or however you pronounce it, and this part will be known as your amplitude, and you could either here to here and state that it is the wavelength. Either 2 of this, there you get 2 marks already. Bam, free. Okay, ladies and gentlemen. For those who have no questions, you can start attempting question number 5 already. Once again, you only have 5 minutes. Yes, thank you, my boy. Yeah. Yeah.
Refractive index 0.67. What did I say about refractive index, Albert? If I look at this, I know it's wrong straight away already. Tell me why. Because it should be more. Yeah, it should be more than one. Very good. Something went wrong, right? Somewhere. Yeah, that's more like it, right? And
Guys, you have 1 minute left for question number 5. Good. Bit messy already, but
you continue this line, right? After you draw normal, then you draw this line already, right? After you draw this line already, you just draw the wavefronts. This is the reflected one. And this one you drew it closer to normal, right? Then you make sure that this thing is 90 degrees with your correction. Then you just continue the rest of it now. Draw longer. It's correct already. Yeah.
but you don't have same clear. Yeah, also. C over V, bro. C over V. Speed of light in medium over speed of light in object. Well, guys, check answer for question number 5. Guys, theory question. State what is the meant by total internal reflection? What do I say for total internal reflection? Actually, what do I say? Reflection in more dense where there is no refracted rays. Oh. Yeah. Okay, I'll write something else. Guys, total internal reflection can only occur after your angle has exceeded the critical angle, guys. And the second condition for total internal reflection to occur is that it must be from more dense to less dense. For example, if you piss on the ground, you see a reflection, that one is not called total internal reflection. Right, it must be from the water looking upwards. The answer given is reflection in the more dense material where there is no refracted rays. But I think you could write something similar, right? Reflection that occurs from more dense to less dense material once critical angle has accepted. I think this would be a more logical answer for me. Okay, everyone. Then critical angle, this one is a very common question. You will see it multiple times in your past year paper. Critical angle, how do I define it? Angle where what? Maximum refraction occurs. This is quite a popular one. You need to define this. If you think about it, critical angle, they start to go 90 degrees already, right? After critical angle, total internal reflection occurs already because you cannot refract anymore already. That's why it's known as the angle of maximum refraction. Quite a common question, this one. Okay. Then next. Calculate refractive index. There's only two formulas here. Either sine I over sine R or COV. But in this case here, obviously, this is your C, which is your speed, speed of light in air, and this is your V, which is your speed of light in the medium. In this case, the medium is the glass. So it's literally 3 divided by 2, which is going to be 1.5. There is no units. There is no units for these kind of questions here, guys, because it will be cancelling off each other. Right, so it's just going to get 1.5. And they ask you to show that the critical angle is 42 degrees. So it means to say your n equals to 1 over sine C, and you're supposed to show your C by plugging in your 1.5. 1.5 equals to 1 over sine C. And then you start to do it in your calculator. Sine C equals to 1 over 1.5. And your C would have been shift sine 1 over 1.5. This would have been your working, and you will for sure find somewhere around 42. You'll get 41.8 if you did this, which is the same as 42. Okay. Then after that, the next question here is the drawing question. They say draw carefully without calculation the continuation of the ray through the prism and into the air. Right. So what's going to happen here is, first and foremost, will this part go through refraction? Will it? The answer is no, guys. Any light that's traveling at 90 degrees to the surface will not go through refraction. Even if I have a half glass prism here, okay, and I have one light ray that's traveling in here 90 degrees, it will not go through refraction also, it will go directly straight. Only when it's here, when it's at a specific angle that is not 90 degrees, it will go through refraction or reflection. In this case here, because obviously it's traveling at 90 degrees, you're supposed to continue it straight all the way here. Then after that, you could either use a ruler or no, actually you don't even need to use a ruler. You'll know that here is 30 degrees, right? And here is 60 degrees, right? And you know for a fact that 60 degrees has exceeded the critical angle, which was stated to be 42 here, right? Right, so obviously it's going to go through total internal reflection, right? Which is supposed to be another 60 degrees here. Oh shit. 60 degrees here. And then after that, there's another angle here, right? Where it will bend away from the normal. You're going to have something that looks like this. If you drew it carefully. When you are asked to draw it carefully, you actually need to include your measurements and everything, guys. You don't have to state the angle if you're certain, but I recommend stating the angle so that you can see the information yourself, and then you know whether it's going to reflect or refract or so on. Okay, everyone? No questions, proceed with the next one. done with the whole paper already. So that's the only thing that's making you up. That's a something negative. We have 2 more minutes to time question number 6. I have to go. Guys, you have 1 more minute left. So time question number 6. So question number 6. It says that a ray of light ray passes through a length of curved optical fiber. Draw a diagram showing the fiber and the path of the ray. This one here is obviously your optical fiber drawing, which you're supposed to draw a slightly curved length of wire, right? And then you're supposed to have total internal reflection occurring inside. What's the application of optical fibers again, that we use most commonly right now? Endoscope and internet cable providers are your telecommunication, guys. And in this question here, they say describe one optical fiber in medicine. This one for sure is going to be endoscopes, and you may draw a diagram. I've told you guys before, right? If you want to draw a diagram, you could start off with drawing the stupid Pac-Man. The stupid Pac-Man guy, right? And then you can draw his legs and arms and everything here. They can draw a monitor. They can draw the optical fibers that is going through his intestines and everything. And then there's a camera here. But you gotta label everything, even though this is physics and your drawing can be absolutely dog shit, right? But you still have to label everything, You have to say that this is your monitor, and this is your optical fiber, and this is your camera, and so on. Now after that, the next part is the description already, right? Which you're going to say something like endoscopes in medicine to view internal organs for two. This something along these lines, and you get a 3 mark, right?
Really?
Sorry? I see this answer come out quite a lot in the mark scheme, so I always include it. Just add one more word only. Yes, you must label it, because God knows everyone's drawing is not Picasso. Okay, everyone. If no questions, please proceed to the next one already. Go on, now. We have 1 more minute to attempt question number 7, guys. Boys and girls, check answer for question number 7. Guys, I've mentioned this in class before, and I'll say this again. If your object is placed in between the focal points and the optical center, what lens is this most likely going to be again? It's going to be a magnifying glass, guys. If you, in your exam, you see that the object is placed in between the focal point and the optical center here, for sure this thing is going to be a magnifying glass, which is the most popular question, most popular lens question in your IGs, right? And from here, they ask you to draw 2 light rays from the top to locate the image, right? The first light ray is the same like all light rays, guys. It will always go straight first, then it will cut through the where? The focal point, right? And your second light ray would have cut through the optical center, and you'll notice that these 2 light rays are actually diverging further and further away, right? Then what do? Yeah, you're going to draw virtual light rays that continues the what's it called, the light rays on the left side here until they meet. Wherever they meet, that is where your image will be, guys. You must draw these dotted lines for your virtual light rays, because these are not real light. And because of this, I know for a fact that this thing is going to be virtual. The image producer is going to be virtual, magnified, and upright. For sure, is these 3 characteristics already. Okay, and make sure you label I at the end of the day. And some of the questions, they may even ask you to put the eye where you're going to see the image, guys. Where should your eye location be? Like, not this eye, not eye image, like your I-E-Y-E-I. Where should I place the eye? If the question asks. Yeah, it's going to be somewhere here. Right. Yeah, all these are in my notes. Please refer to it if you're uncertain. Then object O is moved to the left along the principal axis so that it's further from the lens, as you can see here. Right. And it says diagram 7.2 is a diagram of a new arrangement with a new image shown. Underline 3 terms that will best describe the image. Diminish or enlarge? For sure, enlarge. Is it inverted or upright? Real or virtual? Guys, in your exam, if they ask you whether the image is real, how do I define it? How do I know whether it's real or not in your exam if they ask? No.
Yeah.
Yeah, the image is real if it can be projected onto the screen. If it cannot be projected onto the screen, it's virtual. I've said this, hey guys, this question always comes out. They ask you, is the image real or virtual? And you're supposed to explain why. You're going to say that it's real because it can be projected onto the screen. It's virtual, it cannot be projected on the screen. Then you get your 3 marks already. Oh, they don't even ask you to draw the light rays. But if they ask you to draw the light rays, it's going to be something like this. They don't ask you to draw a light rays, you don't have to waste your time to draw a light rays. But if they do ask you to draw a light rays, it could be something like this. Okay, guys. Anyone has any questions from this part yet? If no, please proceed to the next one. We're running on time already.
Actually, if I open that back, I think I'll show you everything. Yes. Not all very fathers of experience would be recalled to the website. Because fire that we briefly why give this out and I think it's probably under over time can be good. Well, you can be very quick, very yeah. I'm very because I will be you are finding current and what the you agree and this radio already now and we're not going to find Yeah, so you remind me to need why you have power here. Why you kind of
Guys, sorry, check my answer for question number 8, guys. Okay, so what does this question want from you? It says that on figure 5.1, draw arrows to indicate the pattern and direction of the electric field. Should it be inwards or outwards, this one? Yes, it's definitely inwards. And when you are asked to draw, it will be best if you draw at least 4 of them, which the only pattern logical one here is going to be this. If you draw more than 4, it's acceptable also, right? But you must draw like equal distance apart for the electric field to indicate that they have constant electric field strength around the charge. Right. Now after that, it says that a smaller uncharged metal sphere S. Oops. Yeah, just draw arrows on. But I recommend this drawing 4. Minimum 4 is good enough already. Okay, then after that, a smaller uncharged metal sphere S is suspended by a plastic thread and brought close to the negative charge sphere. Figure 5.2 shows the 2 spheres here. And it asks you to draw, by drawing on figure 5.2, indicate the distribution of charges on S here. Now, obviously, more positive charges will be on the left and more negative charges will be on the right. Oh, by the way, you must draw equal amounts. Like, for example, if you draw 3 positive charges here, you better draw 3 negatives here, guys. Don't try to be funny and add extra. Right. I'm going to draw a positive. Okay. Then after that, state what happens to S. Again, this question is a bit weird. This and this, I think, is the same thing. I think. But let's see. Yeah. They're going to say that the negative charges is being repelled to the left. Negative charges on sphere S is being repelled to the right. Yeah, I don't know why they have this. It's like, I think they're running out of questions here. Negative charges on sphere S is being repelled to the right. Okay, then after that, an earth wire is touched against S. Describe what happens in the wire and state how this affects the charges on S. So what happens is right now you have an earth wire here, right? What charge will be induced on the sphere S? Positive or negative charge? Huh? If I have an earth wire here connected, will it become positively charged or will it become negatively charged? It's definitely going to become positively charged because the extra negative charges here will be repelled by this guy down through the earth wire, right? And so it will become positively charged. Then you're going to say, Lord, describe what happens, right? You're going to say negative charges from sphere S will be repelled down through the earth wire, making S okay, charge. And bam, you get your 2 marks again. Oh, yes. What's the main factor that affects whether it's an insulator or a conductor? Yeah, it has to be free moving electrons. You're going to say that metal sphere S have free moving electrons. While the plastic thread has electrons embedded. Yeah. You say it's not free moving. If you don't write embedded, you just say that do not have free moving electrons. It's the same thing. Okay. Everyone, if you have no questions, please proceed with question number 9. We're running out of time already. You once again have 5 minutes.
What? I don't prepare this. Yeah, very resistor. It's about clear moment. Only I no. It was always for the and yeah, especially that. Yeah, I'm sure very resistant. No, it is a thermistor very resistant along with the arrow. Yeah, so the variable resistor is an arrow between this resistor, right? Then I have an arrow between. And when your variable resistor always point down, so this can really see it yesterday. Let's put point it up, right? Growing. It's something good. Hey, I do Aaron. When what I would Aaron is the light dependent. Variable is doing I think what and we do like a span. Both the same business, maybe you need to know or you don't know what's going on with the customer. We got the bump. Yes,
Since the figure 8.1 shows a part of the low voltage lightning circuit containing 5 identical lamps, complete the circuit by addition of components as necessary so that the total current from the supply can be measured. What do you use to measure that? Definitely an ammeter, right? So you just place an ammeter here first, right? Then it says that the brightness of lamp E can be varied. The only thing that we can vary the brightness is by controlling the current, right? And the only way to control the current is by implementing a rheostat, otherwise known as a variable resistor here, right? And then it says that lamps C and D may be switched on and off together, whilst A, B, and E remain on. Means to say you're supposed to have one switch here, right? And then you can just connect all of them together already. Sorry? I don't need to connect what? Us. If not, how am I going to complete the circuit? Oh, like 2 of this like this? 10. 10 will be the same thing. Alright, everything correct already, yeah. Then next, after that, all 5 lamps are marked with 12 volts, 36 watts. Assume that the resistance of each lamp is the same. Calculate the current in one lamp when operating at normal brightness. This one here is like, what formula do we use, Everett? Yeah, P equals to VI. Then I would have been P over V, right? Which is 36 divided by 12, which is going to give you 3 amperes. And then you get a 1. Oh, that's more. Hey, what? Oh, I thought I had 10 questions. I only had 10 pages. Huh. Okay, then after that, the resistance of one lamp when operating at normal brightness. How do I find the resistance? Right now, given voltage, current, and also power, what formula do I use? Yeah, I'm going to use either V equals to IR. You can use this, or if you use P equals to V squared over R, also you'll get the same thing. But for simplicity's sake, let's just use this, right, which is going to be 12 divided by 3, which is going to give you 4 ohms. Yeah, I think most of you guys should be able to do this. Then they said that the combined resistance of 2 lamps when connected in parallel. If they're connected in parallel, the combined resistance is 1 over 4 plus 1 over 4. And then it becomes 2 over 4. But is this the final answer? You must flip it, which is 4 over 2. 2 ohms, because this will be 1 over RT. And you're going to get 2 ohms at the end of the day. And finally, no, not finally. Each lamp, the energy used by one lamp, 30 seconds, right? E would have been equals to, what's the formula?
equals W02.
VIT, right? Or you could even use E equals to power times time. Or you could use something different also. What do you use?
What done over?
Wow.
Oh shit, no, that's different.
This is V. If you use this formula, it's work done over charge.
I did wrong.
Ah.
Oh, it's
Shut up, like you.
you at what?
Then from here, you're supposed to use your information 36 watts, multiply by 30, and you press it in a calculator, you'll get a nice number 1080. Is it? 1080 joules. And finally, the last part here. The whole circuit is switched on. Explain why the brightness of lamp A and B is much less than one lamp operating at normal brightness. Guys, if you look at the configuration here, A and B is connected in what? It's in series, right? It means to say they have to share what? Voltage. These guys are going to get 6 volts, 12 volts, 12 volts, and 12 volts. Right. So you're going to say that number one, the current here is going to be less, right? Yeah, the current here is even going to be less because there's more resistance in this line here. Right. You can either say that they have less current flowing through it, or you could say that they have less voltage flowing through it, which I assume we have to write both lah. Since they are connected in series, they have a lower voltage per output and have higher resistance. Something along these lines. Yeah, because in this both scenarios, both of them are lower. Okay, ladies and gentlemen. Anyone has any questions that we went through or not? For the 9 questions we went through just now. Anyone wants to clarify anything from what we've talked about just now? Like literally anything. Good. If you have no questions, then that's it for today.